Hello there. Welcome to this video on solving systems of equations by substitution. As always, click the thumbs up if you find this video helpful, drop a comment or question to engage, subscribe for more math help, and please be sure to check out some of the other videos on the channel. We're covering everything you never knew you wanted to know about systems, as well as building a foundation for algebra from the ground up. So be sure to check that out. I wanted to start this lesson by, as always, tying it into what we already know. And most of you, if you're taking Algebra 1 or Algebra 2, you know what the word substitute means. Like you have used this word before. And if we can really focus on what that means, the strategy and what we're about to do will make more sense to you. So to substitute is to replace one thing with another that is equal in function but different in some key way, okay? And maybe you're substituting one color of thing out for another. I guess you could substitute something identical, but that's not how we would practically use it. Now, a key thing about substitution is that you must always take out the original and put the new in its place. So regardless of what you're doing, you take out one thing and you replace it with something else that is equal in value or function, but different in some key way. Let's make this even more real. Okay, let's think about cooking. My dad was diabetic, and so when my mom used to make pies, for my dad, she would take out the sugar and she would replace the sugar with something else, maybe Splenda or stevia or something that wasn't like plain white sugar. Now, those have essentially the same function, okay, equal in function. They are sweetening the pie, but they are different in some key way, meaning one of those is going to make my dad's blood sugar, would have made it spike, and the other one not as much. And so you're making that substitution. And we do this a lot in cooking. Okay, so you might replace eggs with, say, flax seeds or something. So there's different substitutions you can make, but what's key is that whatever you're substituting has to do the same thing in whatever you're making, but will be different in some key way that gives it an advantage. Another example you might think of as is in sports, okay? So if I'm gonna watch a sport, it's probably gonna be baseball, and you might make a substitution of one player for another. All right, now in baseball, maybe you're gonna take your pitcher out, okay? And what you're gonna do is replace your pitcher with another pitcher. So again, equal in function, but different in some key way. So maybe you've got one pitcher and they've been in for 7.5 innings, their arm is tired. So the difference would be we're going to replace this pitcher with another pitcher who has a fresh arm, or maybe you want to substitute a left-handed pitcher for a right-handed pitcher, or so forth. Okay, so think of substitution in these cases. Equal in function, but different in some key way that makes that substitution advantageous. And you always take out the original. So it doesn't do any good making this substitution for the pie here if my mom keeps the sugar in, okay? Like that's not going to serve the purpose. If you try to substitute a player on a sports team without taking out the first player, you're going to get in trouble for that. You can't have too many people on the field. All right, so keep that in mind because that is the process that we are going to go through to solve our systems. We're going to replace one thing that is equal in value or function, but different in some key way that's advantageous to us. So here's the general strategy. I'm going to give this to you in words, okay, and kind of walk through it verbally and in writing, and then we're going to demonstrate it. So if you want to pause the video as I'm going through these, make some notes, go for it, okay? One good thing about doing a video lesson is you can pause it for as long as you want. So first thing is we'll choose one of the equations in our system and solve it for one of the variables. Hint, look for a variable with a coefficient of 1. So if you have, say, 3x plus y equals 2, you want to solve for the y because the coefficient of the y is 1. If you have x minus 4y equals 5, in that case, you would solve it for x because the coefficient of the x is equal to 1. If it is already solved, so if you've got a system where one of the equations is already solved for x or y, meaning x or y is already by itself, then you would not do this step. And if you've got none of your variables with a coefficient of 1, then my sincere advice would be use a different strategy. I mean, you can use substitution, but I would recommend using a different strategy. Substitute that expression into the other equation, and it is important that it's the other equation. So you're going to choose one of the equations, and now you need to substitute that into the other one. If you substitute it into itself, you're going to end up with this true statement, and your problem's going to kind of dead end. Now, if you're wondering what does she mean by that, go check out the practice set that is linked at the end of this video or in the description box to go and see that, because I demonstrate that, what happens if you don't put it into the other equation. You will end up dead ending in your problem. Solve for one variable, and the advantage to our substitution is that we're going to go from 2 variables down to 1 variable. So we're going to have 2 equations that both have x's and y's in them, and we're going to end up with an equation that only has an x or only has a y, which is going to allow us to solve for that 1 variable, and then substitute that value into either of the original equations to get the value of the second variable. Once you get there, you just kind of pick whichever is going to look like the easiest route. So those are the 4 steps of a general strategy for how to do this. There are some choices to make along the way, so make sure you're not just copying off of your neighbor or off of Gauss or Photomath or whatever your whatever the thing is that you like to use, okay? And you're working the problems on your own. Okay, so let's take a look at this one. This will be our first example. Now, in this example, both are already solved for y. So this is maybe the most straightforward version of this. And what I'm going to do is start by just copying one of these equations over. So I'm going to say y equals, we'll just say 2x minus 1. And then I'm going to do this little move. I'll do this once in a while. I do it in the practice set as well. Okay, I'm going to highlight the y. Now, looking at my other equation here, I know that y is equal to 1/2 x plus 2. So what I'm going to do is take that 1/2 x plus 2 and substitute it in for the y. So we're going to have 1/2 x plus 2. And that is equal to 2x minus 1. Now, another expression you might hear, and your teacher might say this, is set the equations equal to each other. And the idea behind that is that if you have 2 things that are equal to the same thing, they're both equal to y, then they must be equal to each other. So 1/2 x plus 2 must be equal to 2x minus 1 because they are both equal to y. Or you can think of it as the substitution. And now here's our advantage. Now we just have an x. Now I've got that 1/2 in there. What I'm going to do is try to clear of that 1/2. Okay, and I'm going to do that by multiplying by 2. And same thing over here. Do the same thing to both sides. 2 times 1/2 is 1. 2 times 2 is 4. 2 times 2x is 4x, and 2 times 1 is 2. And what that did was it cleared the fractions out. You do not have to do that step. Okay, you could change the 1/2 over to a 0.5 and just work with the decimal. That's totally fine. I'm in favor of keeping my x's positive. So x minus x is 0, leaving me with 4. 4x minus 1x is 3x. Then we'll add 2 to both sides. 6 is equal to 3x. Divide both sides by 3, and we get x is equal to 2. All right, and there is our solution for the x. X is equal to 2. Now, next step, take that 2, and you got to plug it into either of the original equations. Either one will work, and solve for y. Remember, you're looking for the values of the variables. So something that I've seen a lot of in my classes is students will get x is equal to 2 and they'll stop. And I'll have to go back to what is the definition of a solution to a system. It's the values of the variables that make both equations true. And so you would need both the x and the y value. Don't stop partway through. I'm going to pick the second equation because that one does not have a fraction in it. So if I have the option of avoiding a fraction, I'm taking it. Okay, and I did that to just highlight what we're going to do. We're going to take that x out and substitute in the 2. So, and I don't know why I put the y there, like y. So y is equal to 2 times 2 minus 1. 2 times 2 is 4, and 4 minus 1 is 3. So you could write your answer as x equals 2, y equals 3, or as the ordered pair 2, 3. Now, I marked this off so that I could see, like, I don't want to write in this area, but what you should do is check it by graphing, okay? So once you've practiced your substitution and the mechanics of this, go ahead and like pop it into a graphing utility, see if you got it right. So let's take a look at that. And there's the equations, y equals 1/2 x plus 2 and y equals 2x minus 1. And if I look over here, there are the two lines and they are intersecting at the point 2, 3. All right. And you might be wondering, well, why would I do all that work if I could just dump them into a calculator? Well, honestly, if all you needed was the answer and you weren't practicing a concept or a skill, sure, go ahead and do it. That you will see on a lot of your upcoming standardized tests and stuff that you do have non-calculator portions where you would not have access to it. And there are honestly times where you could probably do it faster out by hand than by graphing it. But certainly go ahead and take a look at the graph to check it. Now, this one does require us to do that first step. And remember I said, hint, look for a coefficient of 1. So this has a coefficient of -2. This has a coefficient of +5. This has a coefficient of -1. But right here, I have a coefficient of 1. And so that is my determining factor in what I want to solve for. Remember that to solve for something means to get it by itself. And so if I'm going to solve for y, I want to get the y by itself, I can do that by adding x to both sides. -x plus x is 0, giving me y is equal to 5 plus x. Now, here is where you need to plug it into the other equation. Don't write this down, okay? If you were to plug that into the same equation that we just started with, so you're going to take the 5 plus x and substitute it in, just watch what happens, okay? So we get 5 plus x, and then we'll have -x plus x is 0, and we get 5 equals 5, and that essentially dead ends on us there where it doesn't get us to the value of what we want. So you definitely want to pick the other equation. So let's go ahead and pull that other equation. -2x plus 5y equals 22. And once again, I'll just go and highlight this in another color so we can see it, okay? And we are going to take that expression and plug that in for the y. Remember, take the original y out, all right? Take it out, take it out, take it out. When you're substituting, you've got to take out the sugar. You've got to take out that picture before you put in something else. And we know that this is equal because we know y is equal to 5 plus x, but it's different in an advantageous way because I've gone from 2 variables down to 1. Distributing 5 times 5 is 25 plus 5 times x. -2x plus 5x is 3x. Subtracting 25 from both sides, we get 3x is equal to -3. Divide both sides by 3, and we get x is equal to -1. And then we can plug that in anywhere we want. I am going to pick this one because it looks nicer, but I want to be careful. I've got a negative in front of the x, and then the x itself is negative. Okay, be real careful with that. So you got the negative that's in front of the x, and then you have another negative that is coming in on the value of x. So make sure I can try to color code that for you. The opposite of -1 is +1. And subtract 1 from both sides, and we get y is equal to 4. So we get the point -1, 4. Now, you might be thinking, well, what happens if I pick the other equation? What if I'm scared of that? So over here on the left, I'm just going to show you what happens. So you plug in x is -1. -2 times -1 is +2. Subtract 2 from both sides, and we get 5y is equal to 20. Divide both sides by 5, and you get y is equal to 4. So it really does not matter which one you pick. So pick whichever one you like. And let's go ahead and check that by graphing and see what we see. There's the two. Now, what I love about Desmos is Desmos, you don't have to put it in what's called y form or slope-intercept form. You don't have to solve it for y. You can just dump them in. And here we can see the point of intersection is -1, 4. So we have confirmed it by graphing. All right, last example. The length of a rectangle is 3 more than its width. The perimeter is 30 units. Find the length and the width. So 3 more than would be +3. Okay, if I have $3 more than you have, and you have $10, and I have 3 more, then I have $13. Okay, 3 more would be add 3. You also need to know this vocab word, which is perimeter, which is the distance around the outside of a figure, any figure, okay? Now, I strongly recommend drawing a picture. So if you are looking at a word problem and the word problem says something about a rectangle and you have not drawn a rectangle, draw a rectangle, okay? It's like proof to your teacher, like, yep, I tried this. Draw a rectangle. Let's label the width and let's label the length. Okay, and here we have another width and we have another length. The perimeter is 30 units. So if I have length plus width plus another length, so again, the distance around the outside, that's 30. And then a lot of times you'll see this as a formula where people will say, okay, L plus L is 2L and W plus W is 2W. And so there's our perimeter. Now, what we also know is that the length is equal to 3 more than the width. And there's my system. Okay, so the first equation in the system is the one with the perimeter, 2L plus 2W equals 30. And the second one is how the length and the width are related to each other. So the length is the width plus 3. And now we're going to go ahead and do our substitution. So plug that in right there. Remember to take out the L. Probably wondering, why does she keep saying that? Because I've seen a lot of people not take the L out. And now we've got just one equation with one variable. So we'll go ahead and distribute through. 2W plus 6 plus 2W equals 30. 2W plus 2W is 4W. Subtract 6 from both sides. So 4W is equal to 24. Divide by 4. And we get the width is equal to 6. And we are asked to find the length and the width, sometimes known as the dimensions. But we know that the length is the width plus 3. So it'll be 6 plus 3 or 9. And there you have it. Okay, so we have the length and the width, and this one you probably would not write it as an ordered pair because we have absolutely no way of knowing like what's your X and what's your Y. You might sometimes see that, but usually with a problem like this, you would just say width is 6 and length is 9. So what are the pros and cons of this method? Pros is it's very intuitive. It builds off what we know substitution is. If you have done any cooking or you follow any sports or you've had a substitute teacher in your class, you know what substitution is as a general rule, and then you can see how it works in this method, which makes it an intuitive method that you know how it makes sense to you. It's also very mechanical. There are some decisions to make, like which of these variables do I want to get by itself, but no big decisions. You don't need to analyze a lot of math or have a lot of great number sense to be able to do it. So those are usually what people like about it. For cons, I said it can get very messy. Many expressions can involve fractions. So if you check out the practice set, the first couple practice problems, like heads up, they have fractions in their answers, and you can see where that can get messy. You can also, when you're solving one of the equations for a variable, if you don't have a coefficient of 1, you can end up substituting a fraction into an equation, like a fraction with variables in it, into an equation. So it can get very messy, and typically if it is like that, we would not use this method for solving it. Don't forget, check out the practice set for this lesson. It is linked in the description. Like and subscribe for more math content. Drop a comment or questions, and check out other videos and playlists on the channel, and I will see you in the next one.